Hey everyone. In class on Monday, many groups were struggling with writing the parser for arith expressions extended with variables and let expressions. And I'm not surprised. It's difficult, and it's a lot to put together. Many groups were making good progress. Some groups had even gotten it to work. But I thought it would be useful to kind of actually walk through, now that you've all struggled through it, to kind of show you how I would walk through putting this together, either to get you over the last hump or to kind of solidify what you had already figured out when working on this module. So, okay, so we've got our parser here, and all this stuff is just kind of the basic stuff that we've seen before: parens, reserved op, reserved. The difference between reserved op and reserved is that reserved op is for things that actually use operator symbols like plus, minus, times, ampersand, and reserved would be like for words, like keywords, like let, in, for, while, those kind of things. With integer, white space, identifier, right? We have now that will parse, any variable name. And by the way, it automatically handles making sure that you can't use, for example, the word let as a variable name, because we've said that let is a reserved word. And the idea is that we're going to add an atom is kind of a thing that we can just look at the first character of it and figure out what it is and parse it right away, or the first few characters at least. So if it's an integer, we just look and say, oh, it starts with a digit, it's an integer. If it starts with a parentheses, we know that it's a parenthesized thing, and we can just do that. But we're also going to add, if it's a variable, that'll be an atomic thing, and a let expression too, because if you see the word let, then it's definitely a let expression. As opposed to a more general expression that could have multiplication, addition, and subtraction. Like if I see the number 3, I might need to keep going and see whether it's 3 plus something or just 3 by itself. So this build expression parser thing handles that all automatically. We're not going to have to touch this parse arith. We're just going to change this parse arith atom. So we need to add variables and also let expressions. So let's just move it. I don't know. Put it. You don't have to put it on separate lines. You can put it all on the same line. Especially when it starts to get longer, I like to break it out on separate lines so that it's not just like running off the right end of the screen. So the variable case is very easy, and it's going to be very similar to the integer case. Right? We want to say we want to parse an identifier, and if we see that, that's going to return a string, and we want to wrap up that string inside a var constructor. Actually, I guess I didn't actually change my data type. Okay, we should do that. So we'll have a var case which has a string, and we'll also have a let constructor that has the name of the variable, the expression that is the definition of the variable, and then the expression in which that variable can be used. That whole thing will be in arith. Okay. And now for the let case, I'm just gonna make a helper parser. We'll just call it parse let, and we'll put it down here. So parse let is going to be also a parser arith, but it's specifically looking for a let expression. So here's how I'm going to start doing this. I'm going to try to just write down the sequence of things that I expect to see. And at first I'm just going to write them down in sequence, which is not going to be the right thing, but at least I'm going to have all the right things in the right order. Okay, so the first thing that I expect to see is the word let, and I'm looking here at this concrete syntax right here. Right, so the concrete syntax is described here, so I want to kind of translate that into parser combinators. So I first see the word let, so I can say reserved let. Then, you could read this as and then. I want to see a variable, so that will be an identifier. A variable name, right? I just want it as a string, because ultimately I'm going to take these things and put them inside that let constructor, and we just want a string there So that's fine. Then I want to see reserved op. I want to see an equals sign, and then, and you could I don't know if it matters if you use reserved op or reserved for this. Technically, we should use reserved op. It might work either way. Then we want to see an arbitrary arith expression, so we can just say parse arith. And then we'll see another reserved word, which is in, and this is going off the right edge. That's okay. We're going to clean it up maybe in a minute. Parse arith. Okay, so this is a valid parser that looks for all these things in that specific order. So it has to first see the word let, and then it looks for an identifier, and then it looks for an equals, and then an arith, in, and an arith. And if it doesn't see exactly those things in exactly that order, it's going to fail. However, this is not the parser we want, because right now what this says is it's going to throw all these things away except the result of the very last parser is going to give us an arith, and it's going to return that. So this would be like if you just ignore, if we had a let expression like this here, it would just ignore all of this stuff and just return this expression at the end. But that's not what we want, right? We want it to actually return a let expression using the let constructor. So the key idea here, and this was on the previous module, but it takes some, seeing it a few times to really get used to it and to realize what it can do. Right? The thing here is that we have multiple pieces of information that we want to collect and put inside the let constructor, right? We want this identifier, we want the string that gives us, we want this arith here, and we want this arith here. The other pieces we're going to ignore, right? I need to see the word let, but I can, once I've parsed it, I just throw it away. Same for the equals and for the in. But these three things, the identifier and these two ariths, we want all those things, and we're going to combine them all together somehow. And when we want to have a parser that pulls out multiple pieces of information and then combines them somehow, that's what there's this pattern using the $ operator and then also the star operator, which looks something like this. So we have some function that we're applying to some parsers. So it looks something like this. So this star operator, which we sometimes call app, is basically letting us combine the results of multiple parsers together. And we have to, at the beginning, put a function and then with this application operator that says this is the function we're going to use to combine the outputs of all these parsers. So the first thing to do then is to kind of put parentheses around the pieces that we want to combine. So this is one piece, right? And we're going to ignore this and then return the identifier. The next piece is this, and the next piece is like this. Typically, I'll have all the stuff that's ignored and then like one non-ignored thing at the very end. You could do it a different way, like you could stick the reserved op equals into this thing by using a left pointing, like a less than star operator, but this makes no sense. Okay, so I've got these three pieces, right, and I want to combine them all, combine their outputs. So I'm going to actually use this combining operator here. And then the thing I need to do still is to actually have a function here, right? So something that I'm using to combine all those outputs. And in this case, the thing that I want to use to combine them is simply the let constructor itself. You don't have to use a constructor here. You could use any function you want, right? So, I think even in the previous module you had to do things like, I could also say like, oh, if it's a function that takes these three things, x, y, z, and does something with them, I could do that as well. But in this case, I really just want the let constructor. And I don't know, maybe let's we can just like indent it a little more nicely, makes it a little easier to read. Right, this makes it a little clearer that like I'm taking the let and I'm applying it to three things: the result of this parser, the result of this parser, and the result of this parser. So if we should be able to load this up, run it, so we should be able to say parse sum, parse arith. Let's try some of these examples down here. Well, here's an example. And it looks like that works, right? So we got a let x, and then the first thing is the definition of x, which is times, 4 times 12. And then this is the rest of it is, some expression minus something something. It's got some x's in it. So that looks good. That looks like that works. So that is how I would go through thinking about writing this kind of parser. And at this point, I mean, you basically know everything you need to build arbitrary parsers. So the ability to sequence parsers together, and then the ability to take the results of multiple parsers and combine them using whatever function you want. That's pretty much all there is. Like, there's nothing else that you could possibly want to do, because being able to combine things with an arbitrary function, basically you can do whatever you want. You can parse whatever you want and pull out whatever information you want and combine it however you want.